Hello student, this video lecture is prepared for heat transfer subject and I will discuss the unit number 6, that is evaporation. So what are the contents of these units? First we will discuss what is meant by evaporation. Then I will discuss what are the common examples of evaporation. Then there are some definitions like evaporator economy, boiling point elevation. After that, we will discuss material and enthalpy balance. That means heat balance for single effect evaporator. Then material balance for the solute. Then evaporator types. So there are different types of evaporator like open pan, horizontal tube, standard vertical tube, long tube, forced circulation. After that, we will discuss the multiple effect evaporation system, and there are some comparison between forward feed and backward feed arrangements. And after that, we will discuss the vapor recompression, mechanical recompression, thermal recompression, and at the end of this content, we will solve one problem. So these are the content of your unit number 6, all content. So in today's lecture, I will discuss first 2 to 3 points like evaporation, examples of evaporation, evaporator economy, boiling point, elevation. And if the time permit, we will discuss the material and enthalpy balance. So what is meant by evaporation? It is an operation that is carried out in industry as a means of concentrating a weak liquor or solution by vaporizing a portion of the solvent. Then what is meant by weak liquor or solution? It is composed of non-volatile solute and volatile solvent. So what is the meaning of this? If we are having weak solution, for example, sugar. In sugar solution, sugar is the solute and water is the solvent. So this is called a weak liquor or weak solution. So this solution can be concentrated by using heat. That means portion of solvent is evaporated. And then we get the concentrated liquor or liquid. So this is the purpose of the evaporation. So evaporation is nothing but concentrating the weak solution by vaporizing the portion of solvent. The solvent may be water, organic solvent, whatever it may be. Then generally what is happening when this, if we evaporate the solvent and we get the desired or thick liquor, that solution is also called a thick liquor or concentrated solution. And the generally vapors produced by this evaporation has no value. That means we are condensed that vapor and discarded. That means there is no use of that solvent vapor. We are using only the thick liquor or that solution. Then in drying also we are doing the same thing. But what is the difference between drying and evaporation? It differs from the drying is that the residue obtained in a liquid rather than the solid. So in case of drying, we are also heating the material, but the end product is generally solid in the case of drying. But in case of evaporation, we are having the end product liquid. Similarly, there is another operation which is also called as a distillation. So in distillation, how it is different from evaporation? So it differs from distillation is that the vapors is usually single component, and even if it is a mixture, it is not separated into fraction. So in distillation, we are separated the liquid mixture according to their boiling point, according to their vapor pressure or volatility. And in case of evaporation, we have to evaporate the vapors or solvent, which is a single component. And these vapors we cannot further separate it. We discarded that vapors after evaporation. Then it differs from the crystallization. So what is meant by crystallization? We are again separated the solute and solvent by concentrating the solution. And finally we obtain the crystals by the crystallization. But in case of evaporation, our final product is liquid rather than crystals or solid. And generally in chemical industry, the evaporation is generally followed by crystallization and drying. That means after evaporation we can carry out the crystallization and drying. So these are the three different basic difference between drying evaporation, distillation drying, and crystallization and drying. So generally the common heating media, that means heat source for the evaporation, is low pressure steam, and sometimes solar energy, fuel, electricity, hot oil or flue gases are used for the heating purpose. And what is the heating purpose of the evaporation? To increase the temperature of the solution to its boiling point. Okay, you have to increase that solution, weak solution temperature to its boiling point and supply the latent heat of vaporization of the solvent. So solvent should be evaporated. That heat should be supplied to that weak liquor. So these are the purpose of providing the heat to the weak solution. Then we will discuss what are the common examples of evaporation. So I have already told that concentration of aqueous solution of sugar, that means sugar, before it enters into the evaporator, it is having weak solution or dilute solution. Weak solution means dilute solution. Aqueous solution, that means it contains water. So we don't require that much water. So you have to concentrate that solution. So then evaporators are used in sugar industry. Sodium chloride also we can create the concentrated solution of sodium chloride. Sodium hydroxide, glycerol, milk, fruit juice. So these are the end products of the evaporation. So in this industry, that means sugar industry, these are inorganic chemical industry, organic industry, food products, we are using the evaporation. So now we will discuss how the performance of tubular evaporators are evaluated. Tubular means the evaporator which is having the tubes inside that. That is called a tubular evaporator. So the performance of the evaporator is evaluated in terms of capacity and economy. So what is meant by capacity and what is meant by economy, we will discuss. So here the definition of capacity is given as the number of kilograms of water vaporized or evaporated per hour. So how many kilograms of water is evaporated per hour in that evaporator is called capacity. And rate of heat transfer, that is Q. How we can calculate in the evaporator. So here that formula is given, Q is equal to UA delta T, where U is the overall heat transfer coefficient, A is the heat transfer surface area, and delta T is the temperature difference between the heating media or medium and that boiling liquor. Liquor means solution. Okay. So delta T is nothing but what is the difference between heating media temperature and boiling. So that is called delta T. So you have to put all this value, and from that we can calculate the Q. Note that there are some common parameters or conditions of the feed depending upon the capacity of that evaporator increase or decrease. Okay. Suppose if we are having the feed solution, that means weak solution, at its boiling temperature, then all the heat transfer through the heating media is available for evaporation. And in this case, the capacity is proportional to the heat transfer rate. Okay. So if we are having feed solution at boiling temperature, all the heat you given in that evaporator is directly transferred for evaporation purpose. So the capacity is directly proportional to the heat transfer rate. If the cold feed solution is fed to the evaporator, that means normal temperature, room temperature, the heat required to increase the temperature to the boiling point, and it may quite large. Okay, means first we have to heat that solution or weak liquor, and then that solvent is evaporated. So here in this case the capacity of that evaporator is reduced because we have to use additional heat for the increasing the boiling point of that solution. And when the feed solution of the evaporator is having temperature higher than the boiling point of that weak solution, the portion of feed evaporates adiabatically. That means directly heat is added and the capacity is greater than corresponding to the heat transfer rate. That means you have already higher temperature than the boiling point, so that heat is directly evaporate that solvent. So by doing this, the capacity is increased and also the heat transfer rate increase. Therefore, that type of a evaporation is called a flash evaporation. So this, if you add the evaporator above the temperature of the boiling point, the evaporation is taking place adiabatically. That means no additional heat is required. Delta Q is equal to 0. This is known as adiabatic. So the capacity is higher, very higher, or greater. So this is topic. This is called a flash evaporation. So here I want to conclude this lecture. So today's lecture we have discussed about what is meant by evaporation. Then we have discussed objectives. Then we had discussed what is the difference between drying evaporation, distillation evaporation, crystallization. Then how the heat is used in the evaporator. And then we have discussed the performance, that is capacity. And before that we have discussed what are the common examples of evaporations. So remaining part we will discuss in the next lecture. Thank you.